For this example, we are going to verify or prove that the given function is a solution to the given differential equation. Here's the given function y of x. And here is the given differential equation. Notice it's second order and it's linear and it's equal to the zero function. In order for this original function to be a solution to this differential equation, we must prove the identity here. And so how are we going to do this? We're going to need to take a couple of derivatives and write a proof involving expressions. You've done this before. You proved identities in the past, where we're just going to do it again. So, let's see. To make things neat, let's work off to the side here. And what we're going to need is the first derivative and the second derivative of this function. So let's take the first derivative. Keep your pencil moving. And let's see here. We have that, right? Okay, using the product rule, we get the first derivative. Notice we could take the second derivative and you're going to get a nested calculation. We could simply write this again. And now we're ready to take the derivative of 2 times e to the opposite of x times cosine of 2x. Once again, we could use the product rule. And there we go. We have completed the second derivative. Now we are ready to write the proof. Now, remember how to prove an identity. We first write the left-hand side exactly once. So we must write y double prime plus 2y prime plus 5y. We're going to take this expression and we want to prove that this is in fact equal to the zero function. So this is going to take some work. And all we're going to do now is substitute. So let's see. We have a negative 3 e to the opposite of x sine 2x. And then we have a minus 4 e to the opposite of x cosine 2x. So that is the second derivative. We're going to substitute 2 times the first derivative. And then finally, we're going to substitute 5 times the original function. Only thing left to do now is to collect like terms. So, we have negative 3 minus 2 plus 5 of this term. And we also have negative 4 plus 4 of this like term. That in fact does equal to the right-hand side. And what is the right-hand side? It's equal to 0, or the zero function. Let's put a period there. Let's write a couple of sentences to summarize what just took place. Therefore, you have shown that y double prime plus 2y prime plus 5y does in fact equal 0, or the zero function. Boom. And if you prove that identity, we could also conclude that, thus, y of x equals e to the opposite of x sine 2x is a solution to the second order linear differential equation that's set equal to the zero function. And that concludes your proof. Let's circle our answer. So the answer is actually the entire proof.